Hi, my name is Shannon, and I'm going to be talking about reducing environmental impacts associated with electric vehicle batteries. ICEV stands for Internal Combustion Engine Vehicle. This utilizes a combustion chamber that converts fossil fuels such as petrol or diesel into kinetic energy in order to power the vehicle, while BEV stands for Battery Electric Vehicle, which relies entirely on electricity to power the vehicle, utilizing a rechargeable lithium ion battery. To date, the most common types of vehicles on the road globally are the ICEVs. However, as seen on this graph, current reports have shown that electric vehicle sales are growing exponentially on an S curve, and this growth is expected to continue, while we can expect to see a decline in the internal combustion engine vehicles. This is mostly in part due to the environmental concerns with ICEVs because fossil fuels are a non renewable form of energy, and the combustion of these fuels leads to global warming and air pollution that's harmful to human health. Car manufacturers are pushing for more alternative vehicles that have less of an environmental impact. Shown here is one of many comparative life cycle assessment studies on internal combustion engine vehicles and battery electric vehicles. Shown here, the environmental impacts associated with the production phase of the battery electric vehicle is much higher than that of an internal combustion engine vehicle, and this is due in part to the battery production as shown by BP on the graphs. The production of the battery involves the extraction of raw materials, which include metals like cobalt, lithium, nickel, and copper. The mining for these materials contributes greatly to CO2 emissions, nitrogen and sulfur oxide emissions, as well as particulate matter emissions. And these environmental impacts associated with battery production can be reduced by introducing a circular economy shown in the graphic here. Once the battery reaches a state of health no longer suitable for continued use in an EV, it's typically still able to be used for secondary life. On a larger scale, these batteries can be repurposed towards energy storage for grid support, and on a smaller scale, they can be repurposed for electric bikes or electric scooter applications. And then once that second life of the battery reaches its end, it will then be sent for recycling. During recycling, valuable components are able to be recovered, such as the metals mentioned previously, and introducing a circular economy into the life cycle of a BEV will reduce the need to extract the raw materials, which lowers the environmental concerns with the battery production. From an environmental impact perspective, recycling the batteries can lead to a 70% reduction in CO2 emissions and energy consumption related to the transportation, extraction, and refining of raw materials, which will make the electric vehicles an even more sustainable option going forward.